Hello everybody and welcome back to another video, and in this video I will solve problem Lena in matrix from round 798. So let's get started. So in the problem we have been given a matrix of size n comma m. So it looks something like this. It has n rows and m columns. Also, all the cells have been colored either white or black. So the matrix looks something like this: white, black, blacks, black, something like this. So for such a matrix, we have to find a cell in the grid. We have to find a cell in the grid such that the maximum Manhattan gap from a black cell is minimized. Find a point such that the maximum Manhattan gap from black cell is minimum or minimized, you can say. So that is what we want to solve in the problem. So how can we do this? First of all, let's try to rephrase the problem. So basically we have to find a point. We have to find a point such that it has the minimum maximum Manhattan gap from a black cell, right? That is the problem. We have to find a point such that it has the minimum maximum Manhattan gap from a black cell. So how can we do this? So if you have seen my last videos, you must have seen that whenever we have to minimize something or maximize something, or we have to find minimum maximum or maximum minimum, the very first thing that you should think about is binary search. So if you have to minimize something or maximize, or you have to find like maximum minimum or minimum maximum, the very first thing that you should think about is binary search. So let's see how we can apply binary search on this. First of all, we will not try to find the point first. We will first try to find this minimum maximum Manhattan gap. And we will find the point alongside. So our main focus will not be to find the point. Our main focus will be to find this minimum maximum gap. And while we are finding this minimum maximum gap, we will find the point alongside that, right? So the point is not our main focus as of now. We will try to find this minimum maximum Manhattan gap. So how can we find this? So let's say our answer is equal to x, right? So it is the minimum maximum gap that we want to find, right? So it is the minimum maximum Manhattan gap that we want to find. So it means that there is some point in the grid, or there is some cell in the grid, such that all the black cells, let's cover the black cells with this. It means that there is a cell in the grid such that all the black cells are inside the gap of x. All the black cells are at most at the gap of x. So if you draw a Manhattan gap circle of size x, all the black cells will lie inside that. And similarly, if you draw a circle of Manhattan gap x plus 1, all the black cells will obviously also lie inside that. But if you try to draw a circle of size x minus 1, there will be at least one black cell that will lie outside that, right? So using this, you can see that we can binary search for this radius. Answer for this is yes. But answer for the size x minus 1, where the radius is x minus 1, we can see that at least one black cell will lie outside that. So answer for that will be no. Right? So you can like see how binary search will work. So we will binary search on the radius. As long as answer is yes, we will keep decreasing the radius and when the answer is no, we will keep increasing the radius. So that will be our parameters for the binary search. So let's try to do the binary search. So we will binary search on the minimum maximum Manhattan gap from black cell, obviously, from black cell for any point, So our starting parameters that are that is low will be equal to 0 and high will be equal to n into m. So we will define our mid as low plus high by 2, and now we will try to check if mid is a possible radius. So how can we check that? So for that we will iterate over all the points. So iterate over all n into m points, and if you are able to find a point, if you are able to find a point such that all black cells have gap, or such that all black cells have gap less than equal to mid, that is you have found a point in the grid such that all the black cells lie inside the radius of mid, right? So yeah, you can say that, yeah, so our answer is possible. So now we have to check for a smaller radius. So here I will update my high is equal to mid minus 1, right? So now I will try to check for a smaller radius. Also I have found a point where radius is equal to mid, right? So it can be our possible answer. So the given point, right? So this given point can be our possible answer. So we will store this point. So store this point as answer. And if we find a point with smaller answer, we will update this answer. Otherwise, if you don't find any such point, then you can say that the required radius is greater than this. So you will update your low equal to mid plus 1. So So that will basically be the logic that you will follow, right? And as you can see here, we are binary searching on the minimum maximum Manhattan gap, but we are finding the point alongside. When we are decreasing the radius of our circle, we are also updating our answer point, right? So let's try to analyze the time complexity of this. So first of all, we are running a binary search that is log of n into m. This time complexity is for binary search. Also we are iterating for every point, right? We are iterating over all nm points. So here you can add an extra n into m complexity, n into m is of order 10 to the power 6. So you can see that our complexity is already around 10 to the power 7. So we cannot add any extra factors into this. But if you check here, we are finding if all the black cells have gap less than equal to mid. How can we do this in constant time, right? We are iterating over all n into m points, and for every point we are checking if all the black cells have gap less than equal to mid. How can we do this in constant time? We have to do this in constant time or in log time. If we are not able to do this in log time or constant time, we will TLE here, right? So this is for iterating over all points. Now there is some hidden time complexity. Let's call this time complexity x. This is for checking. If all black cells have gap less than equal to mid. So we have to do this operation in O of 1 or O of log something, right? In O of 1 or O of log something. Because if we take like n or m complexity for doing this, our solution will TLE. So how can we check if all the black cells have a gap less than equal to mid for a given point? So now our problem is, for a given point, let's say I comma j, and given radius, let's say mid, check if all black points lie in less than equal to mid in constant or log time, So how can I do this? So let's try to draw our matrix. So let's say here is my point, and if you try to get a point here, let's say this is ij, and we know that our radius is mid, right? So a point on the extreme left that will lie inside our radius will be I comma j minus mid. Similarly, on its right side here it will be I plus 1 j minus, it will be I minus 1 and j minus mid plus 1. Similarly, so on up to here, where you will find I minus mid comma j. Similarly, on the downside you will find I minus mid comma j. Similarly, on the right side you will find I and j plus mid. So you are able to see these 4 lines, right, that form this area, right? So all the points inside this area will have a radius of less than equal to mid, or a gap of less than equal to mid. So all our black cells must lie inside this area, or inside this rhombus, you can say, because it forms a rhombus. So here is my line 1. Along this line it's a diagonal, so I plus j will be constant. Similarly, along, let's call this line 2. Along this line also I plus j will be constant. Let's call this line 3. Along this line I minus j will be constant, and along this line, let's call this line 4. Along this line also I minus j will be constant. So what you can do is you can store I plus j and I minus j value of every black cell. So if there is some black cell here, so you can store I plus j and I minus j value of every black cell. And if some black cell lies outside this rhombus, you can just compare it with these 4 lines, right? If I plus j value of this black cell is less than my line 1, then you can say that my black cell lies outside the rhombus, so my given radius is not enough. Similarly, if there is some black cell whose I plus j is more than line 2, then you can say that yes, it lies on the right side of the line 2, so it lies outside my rhombus, so my given radius is not enough. Similarly, you can check for line 4, and similarly you can check for line 3. So using these 4 lines, you can check if there is some black cell which lies outside your given rhombus, and if there is some black cell outside your rhombus, you can update your low value, and if all the black cells are inside your rhombus, you can update your high value. So using this, you can check this in O of 1 time or O of log n time. It depends on how you implement it. So now you have a solution, right? Now you have a complete solution. So let's write its steps. First of all, binary search. on the maximum Manhattan gap from black cell. Set your low equal to 0 and high equal to 0. Sorry, high equal to n into m. Then you can start your binary search where mid is equal to low plus high by 2, and we have to check if this radius is possible. If this radius is possible, complexity of binary search will be O of log of n into m. Then so now to check this, we will iterate over all the points. So iterate over all points. Iterate over all points n into m, and for every point, complexity of iterating over all points will be O of n into m. Then for every point, define 4 lines of rhombus. Define 4 lines of rhombus. These 4 lines will be what? I plus j minus mid, I plus j minus mid. Similarly, it will be I plus mid plus j, I guess. I plus mid plus j. It is better to write I plus j plus mid, I minus j minus mid, and I minus j plus mid. Using these 4 lines, check if any black point lies outside the radius. If all points are inside the radius, then it's a viable radius. If all points are inside the radius, then we know that yeah, it is one of the possible answers that we can have in the future. So update your answer to the given point, right? Update your answer to the given point and try to look for a smaller radius, that is update high equal to mid minus 1. Otherwise, if you find some point, if you find some black cell outside the rhombus, then you can just continue. And try to go for the other point, right? And in the end, if you are not able to find any such point, you will update your low equal to mid plus 1, right? It means that you will not able to find a radius that had all the black points inside it. So now you are trying to expand your radius, right? So that will be a solution for the problem. I hope I am able to give you an idea, right? There is also a solution that does not use binary search, but I will not explain that because I think editorial explained that very well. So you can go and read the editorial, and if you guys have a doubt, you can join my Discord server, and I can try to explain you there, right? So that was a solution, and if you want to see the code for this, here's my code. So I am keeping 2 sets, I plus j and I minus j, so that I can search in log time if there is some black cell that is lying outside the radius. So that is storing I plus j and I minus j to check position of black cells with respect to rhombus. Then I keep my low equal to 0, my high equal to n into m, and I keep my answer equal to 0, while low is less than equal to high. So this is my binary search. And I keep a variable is possible to check if I was able to find a point that that satisfies the given radius. So I will iterate over all my points, that is I iterate over all nm points, and I try to find if all the points lie inside my rhombus. And here I check using 4 lines. If all points lie inside the rhombus, and if they do, and if they do, given point can be a viable answer. So update that and try to look for a smaller answer. So here I set my is possible equal to true, and when my is possible is equal to true, it means that I found a point that satisfies the given radius. So now I will try to look for a smaller radius. So I update my high equal to mid minus 1. Otherwise, if I was not able to find any such point, I update my low equal to mid plus 1. And in the end, I just print my answer. That is answer dot first and answer dot second. So that was the solution to the problem. And if you guys have a doubt, do let me know in the comments, and I will be happy to help you out. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is 0 hidden fees, there is 0 upfront fees, and they are granting you a minimum package of rupees 5 lakhs. And the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.